In addition to branching, it's also possible to control the flow of a program using loops. So loops enable sections of the code to be executed repeatedly. The code inside of the loop can be set to be executed a predetermined number of times until a particular condition is met, or forever. A loop that runs forever is known as an infinite loop. So the first loop we'll look at is called a while loop. And as you can probably guess from the name, a while loop is one that is repeated for as long as a conditional expression is true. So while that expression is true, the loop will just keep being repeated. So there's a conditional statement that gets evaluated, and if it's true, an associated code block inside the loop is executed, and then the conditional statement is evaluated again. If it's true, the statement's executed again, and this goes on and on and on until the statement is no longer true, and then we drop out of the loop. So this is easy to see in the flow chart. So the flow of the code will go down. We'll get some kind of statement, so such as I less than 10, for example. So if I is less than 10, if that's true, yes, we'll execute some specific code. Go around again. Keep checking. So as long as it's true, we'll just keep repeating this loop. So this statement will just get repeated many times, and then at some point the conditional statement will be false and will drop out of the loop. But for example, in an infinite loop, that will not happen. So an infinite loop, that will just keep going, obviously, well, for as long as the device has got power, essentially. So you can see an infinite loop will tend to not break out of that. We'll just keep going forever. So we'll look at how to implement the while loop in C or C++. Look at the syntax. So you can see here, this is the kind of syntax that we use. So you can see we've got while, and we've got these in the brackets. We put the conditional statement inside the brackets. So here we're saying while I is 10. So sorry, while I is less than 10. So if that is true, then the code inside of these braces, obviously the printf statement and this statement will be executed. Then we'll go back, check this again. If it's true, these will get repeated again, and we'll just keep repeating this code again and again until this is false. And when this statement is false, then we'll essentially kind of skip over these two, and we'll jump to here. We'll print end. So we can see we just set up an integer variable I, and initialize it to 0 at the beginning. So the first time we go, so I is going to be 0, so this is obviously going to be true. So we'll print I to the terminal using printf, and I++ this is the increment operator. So you could write I equals I plus 1. So that would do, because the assignment operator works right to left, it would calculate this value and store it back in I. Another shortcut is this, I plus equals 1. So I'll just keep adding 1 to I. Or you could do I plus equals 2, for example, and we keep adding 2 on it. And then I plus plus. So all these three equivalent, they're just completely equivalent, but obviously it's just I++ is the easiest thing to type. So this will increment I. So now I will become is 1. So we'll go back to here, test it. 1 is less than 10, that's still true. We'll print 1. And then we'll increment it again, we'll go to 2. 2 is still less than 10, so you can see that's going to keep printing the values until we get to 10. So when I is 9, it'll get incremented to 10. And then when it comes to evaluate, then 10 is not less than 10. That's false. So we'll jump to the end. So we see if you compile, run that code as you predicted, this is what we'll see. So print out, but then we'll not actually see 10 printed, because when I is 10, that's no longer true, and we'll jump out of this loop. So it's possible to end a loop using a break statement. So a break ends a loop in which it's enclosed. So we're just going to modify that previous example slightly. So now we've put this if statement inside of the loop. So now we're going to say if I is equivalent to 5. So we'll look at that more next. So just notice here, this is a double equals. So we've got two equals signs here, not just one. This is equivalent operator. So if I is equivalent to 5, so if that's true, then the code inside these brackets will be executed. So then we'll execute the break and we'll drop out of the while loop. So you can see, so if you run that code, it's the same loop as we got before, but now when we've got to 5, in fact there's a typo here. So that would still print 5. So when I is equal to 5, that would be true. So we would have to print, it would print 5. And then if I equals 5, then we will break out of the loop and jump to end. So we can break out of the loop using the break command. So in that previous example, we saw that the loop was broken when I is equal to 5, but as I said, we need to use this equality operator. So that's the two equal signs. So it's very, very important to do this, because using a single equality sign instead of two is probably one of the most common mistakes made by beginners, those learning to program, and it results in erroneous behaviour. Because if we just do if you just use a single one, we're just assigning the value to 5. So we're not checking whether it's equal to 5. We're actually saying, we're setting the value of I to be 5. But when an assignment operation is executed, it equates as being true. If you've done the assignment, so that's equated as true. So if we look at the example, this would be a very common mistake to put a single equal sign here. So if we run this, let's see, I is obviously 0 at the beginning, so this is true. So we'll print 0, so we'll see the 0. We'll increment I, so I is now equal to 1. But then when we do this if statement, we say if I is equal to 5. So this is actually assigning the value 5. So this would actually be kind of interpreted as true. And then so we'll break out of the loop and then print end. So that's a very, very common mistake. So just be sure when you're testing equality, use two equal signs, not just one. So in fact, if you've got any kind of loop and it doesn't work as you expect, then it's, check for that kind of thing. That's a very, very common mistake. So we're seeing with a while loop, the conditional statement is evaluated at the beginning of the loop. So in these examples here, we do the evaluation at the top, if you will. So that means if that's false, the code inside a loop will never be executed. We'll just skip straight past. So if in this situation, if this is false, we'll just jump straight to here. We won't even, that'll never get executed. But there's another slightly variation on this called a do while loop. So this is where the statement is now evaluated at the end of the loop. So that means this code associated with the loop is guaranteed to evaluate at least once. This is different than a while loop. So the code in a while loop might never be evaluated, but it's executed. But with a do while loop, it's guaranteed to be done once. So the code will come down. This statement will get executed. Then we'll check the conditional statement's true. So then if it's false, we'll just drop straight out to loop. So we've still executed this once. But then if it is, if that's true, we'll keep executing it multiple times until it's false. Then we'll drop out. So we'll look at the differences here. So these similar setup. This is how you implement a do while loop in C++. So we've got do written at the beginning. Look at the syntax, and open curly brace, close curly brace. So all the code inside of that loop is included between those braces, and then we've got this while expression at the end. So remember as well, there's a semicolon here. So if you compare this to this, you'll see the difference. So this is going to do this first, and then it'll evaluate, but with a while loop, it evaluates first, and then it does that if it needs to. So if we run these two examples, we can see I is 0, so do, so it's going to definitely do this one time, so it'll print 0 on the terminal, then it'll check while I is greater than 0, but that's not true because I is 0, so it's false, so it'll jump out and print end. But we look at the while equivalent, I is 0, so check this first, while I is greater than 0, that's false, so we jump out and do that end. So in fact, the last type of loop we'll see is called a for loop, and this runs for as long as a conditional statement is true. So, but that's similar to a while and a do while loop, but there's two extra parts to this loop construct for a for loop. So we've got an initialization part and then an increment that runs at the end of every iteration. It's very common in loops, you'd be incrementing, like we saw in the previous examples, while inside the loop we might have I++ to increment I. This kind of incrementing inside of a loop is so common that the for loop kind of addresses that. So the initialization and increment are typically used to control loop counter, so that's based on what I was before. So we can see in previous examples we initialized I to 0, so that'll be in our initialization. That's done first. Then we check a conditional statement, so I is less than 10 or whatever, execute some associated code, then do the increment. So this will be like the I++, and that'll be the kind of I equals 0. So they kind of, because the initialization and increment are so common, they're kind of a part of this loop construct. So then we'll just go back. If it's still true, we'll just keep in that loop again. And as soon as it's false, then we'll drop out of the loop. So similar behavior to a while and a do while loop, but now we've got this initialization increment, a kind of a part of the construct. So we can look here. So this is the syntax. So we can see this is our initialization part. So that's the initialization. So that's executed first. So with this code, create a sum variable initialized to 0. And the next thing what gets executed is this initialization for the for loop. So look at the syntax. We use the word for, and we've got these brackets here. And we've got our initialization, our conditional expression, and then our increment. So that's the increment, and this is the initialization. So initialization runs at the end. So the next thing what will happen is an integer I will be created and set to 0, and then we'll print that value, work out the sum. So we'll just add on. So this sum plus equals I is equivalent to this sum equals sum plus I. So we take the value again. This is Simon's operator works say right to left, so we take the value what's in sum, add I to it, and then store it back in sum. So sum's just gonna keep increasing in value. And at the end of that loop, so after that's done, then this increment will happen. So we'll increment I, so I is now equal to 1, and that'll get printed, add it onto the sum again, check the expression and so on. So this is gonna run. So at the end of every iteration, when the loop increments, this operator takes place. And then when this is no longer true, so when it's false, then we'll drop out of the for loop. We'll go here. So if you run this and print, you can see it's going to print out the values from this line. So it's going to print 0 to 9. kind of in the background, it's been calculating the sum as well. So once I is equal to 10, that's no longer true. So that's why 10 isn't printed here. Then we'll drop out and we'll print the sum. So that'll give you the sum of those numbers. So we often come across infinite loops in embedded systems. So we want to keep the code running for as long as the embedded device is powered. So for a smoke detector, for example, you don't want to turn on your smoke detector for it to kind of detect, just do one reading, check whether there's a fire, and then that's the end of it, switches off. We want it to keep checking forever. So as long as it's powered, we want the sensor to keep reading the sensor. As long as it's powered, we want the embedded system to keep reading that sensor. So we come across these infinite loops very often in embedded systems. So it's very easy. With a while, you just do while 1, or you can do while 2, while 3, whatever. Any non-zero value equates as true, so that will keep. But while 1 is the most common, what you see. So while 1, that expression's always true, so it'll just run forever. And in C++, you can say while true as well, because there is this Boolean data type, so it does recognise true and false. So you can do while true. And this is, sometimes you might come across this. I've never ever used this. It's also possible to do infinite loop with a for construct, leaving it empty. But I just don't think that's readable. So like sometimes you might come across it in code you see on the internet, but I never actually, I never do it like that. I just don't think it's as readable saying while 1 or while true. That's not to say you can't do it. So basically, the same functionality can be achieved using any of these different loops. You can get some code what's written with a for loop, and then translate it so it's written with a while loop or a do while loop. You could just refactor the code to use any of those constructs. And it's so when you're writing code and you know that you need to implement a loop, it's kind of up to you to choose which one to use. But essentially, if you know how many times your loop's going to run, then we tend to use a for loop. So this is where we know the number of iterations before entering a loop. So this is if you're counting, if you want to loop over 100 different values, or take 100 sensor readings or something like this. Or you've got an array of n values you want to loop through each of the n values, and you'd use a for loop. So if you know the number of iterations, you tend to use a for loop. But a while or a do while, you typically use them when you don't know the number of iterations. You want to run while a particular expression is true or false, and then if as soon as that statement's not true, it'll drop out. So they use for loops when you know the number of iterations, and while or do while loops when you don't know the number of iterations. So these are kind of equivalent. You can kind of see this is quite a nice example. It shows you the similarity between a for and a while loop, so we can see with a for loop, this is our initialization. So if we did it with a while loop, you just have to put the initialization before. Then we've got the same conditional expression. We want to run these loops for as long as this is true. And then I++, we've got the increment, and that's the appears here. So you can see if you put that inside this bracket, put that there, that would change while to for. That would be equivalent. But just worth noting here that it is semicolon. So you need to put semicolon. It's not brackets or colons or anything. So it is a semicolon you put between each of those. So this just highlight how you can implement a for loop with a while loop. Just want to finish by looking at an example. So this is for a thermostat. So you've probably got these in your central heating system. So with a thermostat, it keeps your house, or at least tries to keep your house at a constant temperature. So you'll set the thermostat to a particular temperature, and there'll be a sensor inside, so a thermometer, what will read the temperature of the room. So it's normally in your hallway or something. So then it'll say if the temperature is less than your desired temperature, then it'll turn the heating off. turn it on. So if the room's colder than you want it to be, it'll turn the boiler on. So the radius will start getting hot. The room will heat up, and then it'll read the sensor again. And if it gets to the point where the temperature of the room is higher than what you want it, it'll turn the boiler off. So this is kind of an example how you can do it in the flowchart. So the first step, often if you can't just think how to write the code directly, it is a good idea to plan it on paper. So this is, if you think about that logical process of a thermostat. So we begin, we read the temperature set by the user, then we read the room temperature. So then we check, is the room too cold? And supposing it is, yes. And then we check, is the room too cold? Yes. So we want to turn the heating on. But before we turn it on, we also want to check whether it's already on. So if it is already on, then we don't have to do anything. We just need to wait until the kind of room temperature comes up to the desired value. So then we'll go back around this loop. And then we're just going to, it might do this a few times. And it gets to the point where now the room's heated up. So is the room too cold? No, it's not. Now it's the right temperature. So we go down here. Now I want to check, is it too hot? Because there's going to be a threshold. It won't be an exact threshold to turn the temperature on and off. So now is the room too hot? If it is, check whether the boiler's on. If it's on, turn the boiler off. So now because we don't want the room to get too hot. And we can see, supposing at the very beginning though, when we find out it's too cold and the central heat is not on, if that's false, then we want to turn the boiler on, and we'll go back and run the loop. There's another situation, so is the room too cold? No, it's not too cold. So is it too hot? No, so we'll just leave things as, so we won't do anything there in this case. So we'll just leave the boiler as it is, because it's obviously, it's not too hot, it's not too cold, it's not too hot. So if it's too cold, if it's not too cold, let me check if it's too hot. And if it's too hot and the central heating's on, then we can turn the boiler off. So if you go through this flowchart, you'll see that kind of some example behaviour of a thermostat. So now you can start to translate this into C or C++ code. So right away, when you look at this, we can see that we've got this loop what just keeps going back. So there's no end to this. We've got a begin block but no end block. So that, when you see a big loop like this, that tells us that corresponds to this while one loop. So we open the while one loop, and you can see all this code then is then tabbed in. So we've come in one tab, and that represents everything what's going on inside. So we know everything between here and here is going to be inside of this loop. So I'm going to assume that we've got some functions. We'll cover functions later in the course. We've got a function what can read the desired temperature, and a function what can read the room temperature. And we'll store those into some variables. So that's going to be like read the temperature set by the user, read the room temperature. The next bit is the room too cold? So then we've got this. So now we've got an if statement. So if room temperature is less than the desired temperature, that means it's too cold. So we can see, then we've got the open curly brace, cold curly brace, and this is tabbed in again. So this code what's tabbed in, we know that's part of that's inside of that part of the loop. So we're gonna now read the boiler. So assume we've got another function called get boiler status. So this is going to return a 0 if the boiler's off and a 1 if it's on. So we'll call that function and store it in an integer boiler status. So we can say, is a boiler off? So if it's off, then we're going to turn it on, so that corresponds to this part of the code here. So is this central heating on? No. Turn it on. So that corresponds to this part of the code here. So the room's too cold. We want to check if it's too hot. So this is this part of the code here, and again, and that's tabbed in to represent the code. What's down here? So if it's too hot, the room temperature is greater than the desired temperature, so that's true. Obviously means it's too hot, and we'll do the same thing again. We'll read the boiler status, and if the boiler's on, we turn it off, so that corresponds to this. So once you've got your flowchart, after a bit of practice, it's fairly easy to translate that into C, C++ code. And you see, there's not just one way of doing it, there's lots of different ways, because you can see, if you recognise like this shape here, because here I've used two if statements, but by looking at where we've got one condition and that's false, we check another condition. That reminds us of an if-else if statement. So, you could have implemented that using that as well. So different ways of implementing some flowchart, but it's always a good idea to, draw out your problem first, and that will help you to translate it into code.